Hi, everyone. I'm Jonathan White, and with me today is Gustavo Serafini. And today we're going to be doing a presentation called Beyond Ramps and Grab Bars, How Case Studies in Prosthetics and Buildings Help Us Understand the Benefits of Universal Design. Today's presentation, the whole idea is to give some case studies. We'll teach a little bit about what universal design is and give case studies from two very different areas, one on prosthetics and one from buildings. And to help us relate to the goals of universal design and teach that universal design is more than just accessibility, and it's more than just designing for the average person, but it's about designing for everyone. So with that, first, I want to start with the goals on universal design. And with those goals is a definition. Universal design is a process that enables and empowers a diverse population by improving human performance, health and wellness, and social participation. And so there are really three improvement areas here: human performance, health and wellness, and social participation. The first goal is body fit, accommodating a wide range of body sizes and abilities. Comfort, keeping demands within desirable limits of body function and perception. Awareness, ensuring that critical information for use is easily perceived. Understanding, making methods of operation and use intuitive and clear. Wellness, contributing to health promotion, avoidance of disease and hazard. Social integration, treating all groups with dignity and respect. Personalization, incorporating opportunities for choice and the expression of individual preferences. And cultural appropriateness, respecting and reinforcing social and environmental context. And so we see here the definition and how those goals fit into each of those improvement areas for universal design. So when we're designing, regardless of what we're designing, whether we're designing furniture, software, or a building, we should be keeping these goals in mind. So now I'll turn it over to Gustavo Serafini, who will talk a little bit about his case study.
Hi, everyone. Nice to be here today. I want to start out with this quote, which is really powerful and telling. It's by Lieutenant Gilbert S. Daniels. He was a lieutenant in the Air Force in the 1950s. He said, "Any system designed around the average person is doomed to fail." And we're going to see why that is. But this leads us into the challenges that we face with universal design. Universal design is rarely used in residential spaces, including furniture design. It's often conflated with accessibility. So of course, universal design encompasses accessibility within its umbrella, but universal design goes beyond accessibility. And the third point, challenge is we still design for the average body. We still have this idea that an average body is a real thing, which Lieutenant Gilberts was trying to point out. So the goals of this section is we want to broaden the perspectives around universal design. And we're going to highlight this through the concept of body fit. And the question that I really want to have in the back of your mind as you go through this is, how can we use body fit to design furniture that isn't just beautiful, but is also comfortable and functional for a much wider range of bodies? So body fit, as Jonathan said before, it seeks to accommodate a wide range of bodies and to encompass various different abilities. So examples: adjustable car seats, eyeglasses, prosthetics, all of these take body fit into account in their design. So in the 1940s, the Air Force had a huge problem. You can see from this cockpit photo, pilots were crashing airplanes consistently. Some of them were passing away. They documented up to 17 crashes in a day. The Air Force conducted a study. So they put 4,000 pilots, they measured over 140 body dimensions. And the premise was, if we get better data, we're going to have a more accurate average to build these cockpits for the pilots. So their discovery here, which is huge, and let's understand this intellectually and intuitively. The average human body is a fiction. Not a single airman fit within the average range, even with just 10 bodily dimensions. So why does this make sense? Some people may have average length of their arms, but their legs are shorter than average. This is true for necks. This is true for, width of our chests, our waist, etc. When they reduced bodily dimensions to only 3.5% of the airmen were average. So the Air Force pivoted. They decided, we're going to design for individual fit. We are going to make our seats adjustable. We're going to make our pedals adjustable, seat belts, bodysuits, etc. The cost was not an issue here. They found a way to do it in an economic way and in a way where the pilots were not crashing the planes. They fit the environment to the person rather than the other way around. So as we get into prosthetics, I was born with several physical disabilities. These are some examples of my prosthetics over the years. These prosthetics, every single one, is highly customized for me and my leg. This prosthetic would not fit any other person. The last prosthetic I did, which is on the left, they took a 3D laser map of my leg before, the 3D laser map of my leg so that they could get every single angle, every single individual feature of my leg before doing the prototyping and the fitting. This makes a huge difference, not only to the way the prosthetic fits, the comfort of it, but I chose a plastic on this last prosthetic because it was a better fit and comfort for me. It allows me to wear the prosthetic for a longer period of time. It supports changes in my body over time, whether I lose weight, gain muscle, retaining water. I don't have to go and pay $20,000 US because I have some body changes. So it's flexible and it adapts to my body over time. So what I think is important to emphasize here with body fit is that we have a spectrum of choices here. We can design for individual fit and make products that are made for one. I would love to have a chair that's just customized to my body. I don't, but it would be great. My prosthetic is. Along the other end of the spectrum, we can get into mass customization, where we design products that have small adjustments for different body types that allows them to feel more comfortable with it, use it for longer, and support their health and well-being. So if we take this into furniture, this is a photo of my car. If we look at this, is a small adjustment in the seat. I push a button and there's extra leg support there for people who are taller or people who are shorter. For me, this makes a huge difference. I like it reclined because I'm shorter. But if we can come up with some design ideas, let's say with couches, where we can have different cushions available that support people with different heights, extra support for legs, for back, for people who are shorter. This is not a huge cost difference, and it's something that will actually feel more comfortable for the people using it. We can also have shorter seats that expand just like the car seat for people with longer legs or shorter legs. With couches, again, this is a company that we carry and we sell, but they customize. At the top, you see the picture, it just looks like a normal couch. On the bottom, though, you can see that there's actually, it reclines. So you have comfort for different bodies, different body positions. And you also have the top piece, which if you're doing reading, if you're sitting for longer periods of time, it supports your neck. So these are some ideas of how we can start to adjust and design furniture in a way that's more adaptable for bodies. So to kind of sum up here what we're talking about, the average body is a fiction. If we keep designing for average bodies, it won't be a good fit for anybody. Second thing, let's ask the questions. What is furniture for? What activities are we supporting? My prosthetists always ask me before I start a new prosthesis, what activities do you want to do? What are you using your prosthetic for? Some periods of my life, I was much more active. So I was playing basketball, I was playing tennis. I needed a prosthetic that was more rigid and was going to support those functions. Are we sitting on our furniture? Are we reading for a long time? Are we watching movies for a long time where we need more support? Or are we using our furniture for casual gatherings? These are all questions that we need to ask as we're designing furniture. Third thing, adjustability. It allows different bodies to get the comfort and the support that they need, and it promotes our health and well-being. We have the ability for the environments to fit our bodies. We have the ability to make things more adjustable for a wider range of people. Why not do it? It's healthier, it promotes our well-being, and it's more inclusive. I really want to encourage designers, architects, furniture manufacturers, product manufacturers who are going through this presentation and thinking about creating something new to say, you have such an incredible responsibility and ability to make changes to our built environment, to give us something that is more adaptable, more adjustable, more inclusive. Let's make this a trend.
Thanks, Gustavo. Shifting gears now, but staying on the same topic of using the goals of universal design, I wanted to show you this other case study that we did. The building you're looking at now is called Griner Hall. It's on the University at Buffalo's North Campus, and it was one of the first buildings built using a draft version of the Innovative Solutions for Universal Design, a universal design certification system. And I say it was built with a draft of these standards under a research grant that we have, because we wanted to test out how well these standards work. And so the reason I'm including it here is because these standards encompass all of the 8 goals that we talked about, including body fit. And I wanted to show you the results that when you design for body fit and the other goals of universal design, that it does really make a difference in terms of how people rate this. So whether you're designing furniture or anything else, by doing universal design, you can help create more satisfaction, greater ratings for usability, and so on. So I wanted to tell you a little bit about that research and what we found. So the objectives of the research were to find out, does a universally designed building provide a better user experience than a non-universally designed building? And do the draft standards contribute to this improved experience? And ultimately, the goal was to improve the usability and effectiveness of the standard, which was eventually done and became the Innovative Solutions for Universal Design at thisisud.com. To do this, we did a few different things. We did guided tours through both buildings. They were both next to each other, both university residence halls, one of which was ostensibly accessible. It was an older building, so it gets grandfathered in terms of some of the requirements. And the other building was brand new. And so Griner Hall was the new building. So we did guided tours where we took people through the building, half of which had some form of disability, half of which were female, half of which were male. And we accounted for many different types of disability. And then the other thing we did were online surveys of the actual residents of each building, and they didn't know the buildings were being compared. The guided tour obviously knew there was a comparison in some way because they went through one building and then through the other. But we altered, half of them started in one building, half started in the other. And the type of things we looked at were a little bit different. The guided tour and online survey. The online survey focused on things that people in the building might be more familiar with who are living there. But generally, we looked at a lot of different things: public restrooms, elevators, stairways, areas outside. Now, they both shared the same space outside, the same outdoor areas, and you'll see that in the results in just a minute. But we looked at the student rooms, kitchen areas, laundry rooms, lounges, and so on. And we asked them some questions about the residence hall overall. The issues evaluated, in terms of the guided tour, we looked at usability primarily, convenience, satisfaction, and wayfinding as well. And satisfaction, that would be with a number of different criteria. With the online survey, we focused mainly on satisfaction, but also convenience, usability, wayfinding, comfort, personalization, privacy, community, and safety. So a lot of other things we were trying to get at that people who lived in the building would have experience with. So the guided tour focused on usability. How easy or difficult was it to use this, do this, find this place? Online survey focused on satisfaction. So I want to go through some of the results of that research now and show you how a universally designed building really helps improve usability and satisfaction. The chart you're going to see on the screen shows different questions on these surveys. Each point will be a question on the survey. And you'll see, a building that rated very well, that will be a higher mark on the screen. And the building that rated lower will be below that. And so we're plotting here significant differences in the building. So you see very easy at the top, in between, very difficult at the bottom. And you're going to see this go across here. So you see at the beginning here, this green, that's favoring the non-universally designed building. And this blue is favoring the universally designed building. So you can see across all of these different questions, the universally designed building rates far higher. Now, in most cases, they're both on that easy side of the spectrum, but the universally designed building fared better. And so I'm going to go ahead and just show that again here, a little bit slower. And you see those gray areas are where there was no significant difference. So all of these points, these ratings, are significant differences here. And the gray are no significant differences. And so let me show you what that looks like just as a pie chart overall. So on 65% of those items that went scrolling past the screen really fast, the universally designed building rated higher, statistically higher. The non-universally designed building, you see that 6% there, rated higher on 6% of 49, so you can do the math. And there were no significant difference on 29% of the questions. So you see the universally designed building rated statistically higher very often in the building. And when we break it down by ability, whether there was a disability or no disability, you see similar results. Obviously, the universally designed building taking up a far greater percentage of the questions. Now you'll see if people did not have a disability, the non-universally designed building did a little bit better, but so did the universally designed building. So now we're going to take a look at the same chart that's going to whiz by pretty quickly for the online survey. These were all for the guided tour. Now these are the online survey. And so you can see here at the beginning, you see all these no significant differences. Why is that? Well, those are the areas outside that was shared. So it's a good control. And we see here again, how the universally designed building rates higher for most questions. There's a few anomalies here, and I'll talk a little bit about some of those, but very consistently. And again, notice for the most cases, they're above that midpoint. So even though the non-universally designed building still rated fine, but just nowhere near as good as the universally designed building. And so here's the chart for the online survey. Again, so these are residents of the building showing similar outcomes, rating higher 66% of the time in the universally designed building of those questions. And breaking it down by disability or no disability, we see similar results. We're getting a little bit of an anomaly here due to a small disability sample because we're surveying residents of the building. So of the 1,000 or so people who were in these buildings, what percentage of them actually had a disability? It's rather small. And so we're getting a greater number of no significant differences amongst people with disability. But when you still compare the two buildings, the universally designed versus the non-UD, we see 24% to 1%. So obviously the universally designed building, a lot of those questions are rating higher amongst people with disabilities as well. But due to the small sample, we're getting a lot of no significant differences. On the no disability side, we've got similar results, 66% saying, 66% of the questions universally designed building rated higher. So let's take a look at some examples of why this is taking place. So we've got wayfinding as an example. We've got the universally designed building on the left and the non-UD building on the right. And we're looking at finding the entrance and how easy it would be to find the entrance of the building, or how easy it is for your visitors to find their entrance, find their way around. We asked all these sorts of questions. And there are architectural features in this universally designed building that are in the ISUD standard that make it easier to find the entrance, like details highlighting the location of the entrance, prominent signs identifying the entrance, and being visible from likely vehicular, pedestrian, and bicycle approach routes. There was also other good wayfinding systems in the building, like clear room numbering, cohesive graphic design strategy, these colored tiles for each of the wings. But the non-universally designed building had confusing signs like this, giving banks of rooms served by elevators. This also compares the buildings here. Now the universally designed building is now on the right. We've got a very similar circulation plan on every floor as opposed to a different one on every floor. Entrances are all immediately visible right from the front. In the non-universally designed building, those first two entrances you come to are locked. You have to go around a corner, and then there's 4 other entrances to choose from, 2 of which are locked, even though they all look the same. The universally designed building, you can come in, you got one decision point, an elevator, and then another decision point. Follows a well-known double-loaded corridor model, which are, and you see those numbers appearing on the screen, those are standards. In Fargo, you come in, you've got a decision point to go to one elevator or a different elevator, depending on which tower you're going to. You could leave and go to another building that's attached. You go through another locked door where there's one elevator, and then another elevator next to it. One of those serves only 3 floors, and the other serves the whole tower of building 4. Then we had people try to, what you're seeing here is the route to try to find a room. We had people try to find a certain room. They get to the end and the hallway gets blocked off and it's locked, and you have to go back outside and then get buzzed in to get into this space in room 111. So obviously kind of confusing. And so how well did it easy? This is one of the better examples where there's a huge difference. On the guided tour, we see the universally designed building rated way higher than the non-UD one. The online survey, my visitors can find their way around, same sort of thing. Let's take a look at another example, stairways. People often conflate universal design with accessibility. Stairways are an important part of universal design as well. Just because not all people can use them doesn't mean that they're not an important part of design. And so here we can, I think, clearly see in the visuals the differences between the universally designed on the left and non-UD on the right. But we'll talk a little bit about why. So we have these surfaces and edges that are slip resistant. They have a special texture coating on them. High contrast edges with photoluminescent striping and good lighting. And when we look at the open-ended responses, it says it all. They actually are listing innovative solutions for universal design that were used in the building in their open-ended responses without any prompt. Rubber stairs make it so you don't slip. Yellow strips on the end of stairs makes them easy to see and bright lighting. Would they say in the non-UD building, it's a bit slippery in the stairways? Yeah, they're painted. Not good for slip resistance. So how did this translate into ratings? Well, the non-UD building still was rated on the very easy end of things, but not as very easy as the non-UD building, or as the UD building. Online survey, same thing. Again, we see that they're still above this midpoint, that they're easy to use. They're still above that midpoint, but we're seeing a statistical significant difference favoring the universally designed building. And here again, we have the lighting level in the stairway as well. So just 2 points on that rating scale, but it was enough to be a significant difference. Thermal comfort. So I want to talk about that a little bit. So this was a little bit of an anomaly that we saw in the online survey. So the guided tour here, thermal comfort, how easy or difficult was it to set the resident room temperature? We asked them to use the thermostat. Universally designed building, appeared to be easier. But then when we got to this online survey, all the residents said, whoa, the non-UD building is better. Why is that? We wondered. So here's one of the open-ended responses. I think the biggest complaint in my entire suite and a lot of other people I know is the rooms are so cold. Our thermostat has had 72 degrees since the day I moved in here. Honestly, it feels like the same exact temperature as it does outside. Here's the thermostat. So we thought the universally designed building would rate better. It's got a clear display that tells you the exact temperature. Here on the left has an up or down arrow. Pretty easy, you would think, to set. Whereas opposed to the non-universally designed building has this little tiny switch that's underneath it that you can't see, and it just gives you adjustment from cool to warm. So we said, well, this thermostat should be easier to use. What ended up happening is it seems that the residents of the universally designed building were conflating the usability of the thermostat with whether the thermostat actually works and does what you tell it to do. And so what was happening is they would set the thermostat to 80, let's say, and it would tell you like it's set to 80, but it wouldn't actually set it to 80. You actually only had 4 degrees of adjustment. We went to facilities and we found out how it actually works. There's only like 4 degrees of adjustment that you have. So you can set it up or down 2 degrees from the set building temperature centrally, but the thermostat will let you set it to whatever number you want. And so that was the problem. So that's why it would say 72 all the time, because that was the set building temperature was 72. And so they could set it up to 73, 74. Okay, we didn't really do much. And so that's what we were seeing. So just because the design of the thermostat is pretty simple and easy to use, if the building isn't providing the right temperature for the occupants, you get something different. And so lastly, what are the overall ratings? I would recommend this residence hall to others. This translates into more revenue for the university, right? I would recommend this residence hall versus I wouldn't. Even though they're both on the good side, that's a good 0.7 difference there between the two, and that's lost revenue. That's people going off campus to go to different buildings, right? And these are some of the reasons why. I won't get into all the reasons, but why they said that they would recommend their residence hall to others. So those are just 2 quick examples, I think, of why universal design is important in 2 very different realms. Showing why universal design is more than just accessibility, how it benefits everybody, and why you should be using it in your designs. Gustavo, you have anything to add?
No, thank you very much. And I hope everybody enjoyed it. Looking forward to taking questions. And thank you, Jonathan, for doing this together.
Yeah, thank you. Thanks, everybody.